So we're going to start off with this example where an airplane is heading due south at 480 kilometers per hour. Measurements on the ground indicate that the plane's velocity is 528 kilometers per hour at 15 degrees east of south. And we're asked to determine the wind direction and the wind speed. Okay, so let's draw this out. Now for this one, I'm going to ask you to draw the, actually measure the vectors as well as the angle, and you'll see why shortly. So this plane is heading due south at 4.8. I'm going to let 4.8 centimeters represent the 480 kilometers. So that's the heading on the plane. And the ground speed of the plane is 528 kilometers per hour at 15 degrees east of south. Okay, 15 degrees east of south. That's 15 degrees right over here, east of south. And this vector is going to be 5.3 centimeters. We know that this angle in here is 15 degrees. So this is the direction in which the pilot is steering the plane. This is what's actually happening. So your wind vector must be acting in this way. To cause a resultant that looks like this. And we call that wind vector X. So we know that the resultant in this case is 528 kilometers per hour. And we could use the cosine law to solve this since we have this angle up here. So the magnitude of x squared is equal to 480 squared plus 528 squared minus 2 times 480 times 528 times the cosine of 15 degrees. And if I work all that out, I'm going to get 19,575, and so the magnitude of x comes out to be 139.9 kilometers per hour. Now, let's calculate angle theta in here. This is angle theta, because we're going to need this entire angle here for the direction of x. 528 over the sine of theta using the sine law is equal to 139.9 over the sine of 15 degrees. Again, I'm going to work out the math, cross multiply, and I get angle theta is equal to 77.6 degrees. Okay, so when we take a look at this, you have a problem, and the problem is angle theta is clearly an obtuse angle. It's greater than 90 degrees. According to our calculations, it's only 77.6 degrees. So you would only notice this problem if you had drawn it to scale. What's actually happening is your sign ambiguous case. So let's make a note for this. But angle theta is clearly greater than 90 degrees from the diagram. We would only notice this So what's actually happening is this. We're getting this angle in here. This is the angle we're getting. 77.6 degrees. The 77.6 degrees is actually the related acute angle. So what we actually want is this angle in here. That's what we really want. And to get that, we're going to have to take 180 degrees, subtract 77.6 degrees, and that's going to give us 102.4 degrees. That's the angle that we really want. So we can conclude that, therefore, the wind is 139.9 kilometers per hour at a direction of, so this angle in here is actually We could say that's 102 degrees, or we could look at it in terms of how many degrees east of south. And to get this angle in here, you're going to have to take this is your 102.4 degrees, and you're going to have to subtract it from 180 degrees, which is 77.6 degrees. So in the direction of south, 77.6 degrees east of south, or 102